When Earth and the Moon are separated by a distance of 3.84 times 10 to the power of 8 meters, the magnitude of the gravitational force of attraction between them is 2 times 10 to the power of 20 newtons. What would be the magnitude of this gravitational force of attraction if Earth and the Moon were separated by a distance of 1.92 times 10 to the power of 8 meters? So the first thing to realize here is that 1.92 times 10 to the 8 is exactly half of 3.84 times 10 to the 8. So the initial distance, which we'll call r with the subscript I for initial, was 3.84 times 10 to the power of 8 meters, while the new distance, maybe we'll label that r with the subscript new, is half of that, or 1.92 times 10 to the power of 8 meters. We know that the force of gravity is equal to g times the mass of one object times the mass of the other divided by the distance between them squared. We know that initially this is g times the mass of the Earth times the mass of the Moon divided by the distance r with a subscript I, and that's equal to 2 times 10 to the power of 20 newtons. And then over here, we'll calculate the new force of gravity. When we just change the distance between them, it'll be g, mass of the Earth, mass of the Moon, divided by, oh, sorry, this should have been squared back here. So now we're going to divide by the new distance between them squared, which is g mm over r sub I over 2 squared. Now if we apply this exponent, we'll end up with g mm over ri squared divided by 4. Since we're dividing by a fraction here, we can multiply by the reciprocal of the fraction instead, which will result in this 4 being brought into the numerator. Then we can pull it out and we'll have 4 times g mm over ri squared. Now we see that this g mm over ri squared expression is familiar because that was the initial force of gravity, which we're told is 2 times 10 to the 20 newtons. So we can substitute that value in to the brackets. So we'll have 4 times 2 times 10 to the power of 20 newtons, which is equal to 8 times 10 to the power of 20 newtons, since we consider this 4 to be exact. So that's the answer to this problem.